In this video, we're going to determine whether the following series converges or diverges. So here we have the sum from n equals 1 to infinity of 2 to the n over n factorial. So we see that in the numerator we have some constant raised to the nth power over something in terms of n. So we'll probably want to use the ratio test, and we expect that we'll get some sort of cancellation while doing so. So let's recall what the ratio test says. Let's say I have the sum of an, and I can define L to be the limit as n approaches infinity of the absolute value of a sub n plus 1 over an. So if L is less than 1, then the series is absolutely convergent and hence convergent. If L is greater than 1, then the series is divergent. And if L equals 1, then this test is basically inconclusive. So the series may be divergent, conditionally convergent, or absolutely convergent. So in our case, an equals 2 to the n over n factorial, and a sub n plus 1 is 2 to the n plus 1 over n plus 1 factorial. So now we're interested in a sub n plus 1 over an. So this is 2 to the n plus 1 over n plus 1 factorial all over 2 to the n over n factorial. And so this is equal to 2 to the n plus 1 over n plus 1 factorial. And I'm actually going to rewrite n plus 1 factorial as n plus 1 times n factorial, because n plus 1 factorial is just equal to n plus 1 times n minus 1, and so on up until 1. And so this part is equal to n factorial. So this is the same as n plus 1 times n factorial. So I've rewritten that part, but we're not done yet. It's this times n factorial over 2 to the n. So now I see that the n factorials cancel out, and I have 2 to the n plus 1 over 2 to the n. So that is just equal to 2. So now I have 2 over n plus 1. So L is the limit as n approaches infinity, the absolute value of 2 over n plus 1. Now, as n gets really, really large, I'm having 2 over infinity, which is 0, and that is less than 1. So by the first criteria of the ratio test, this tells me that the series converges. If this video was helpful, please like and subscribe, and if there are problems you'd like to see solved, feel free to email them to ashmath1729@gmail.com.